So tomorrow we will have a class and class. Wish everyone the best. So let us, we did partial differentiation. So after the partial differentiation, I'm going to go through the partial differentiation now and we pass through it. So I think that's okay, higher differentiation. Perhaps these are the two things we'll do tonight. So, we are not much time. The class will just be less than 30 minutes. We have already been introducing ourselves to partial differentiation and we've been differentiating. We said if I have f being a function of more than one variable, f is a function of x and it is a function of y. Sure. So my f is equal to 3x squared plus 4x squared y plus 3x y plus 4y squared. So this is a function given to me. Now say the first thing is to get the y, the f, the x when y is constant. This is how that is noted. The f, the x when y is constant. Or just the f, the x. These are not in the second derivative. So the f, the x is going to be equal to, that means I'm going to differentiate with respect to x, and I'm my y as a constant. So we differentiate 3x squared, that is 6x plus, do not forget I'm going to treat my y as a constant. So I'm going to assume my y is 6. So this can be written as 4 times 6x squared. So since 6 is a constant, I have nothing to do with it. I'm going to multiply by 4 by the power of x, which is 2. So 2 times 4, that is 8. So I have 8y, I have an x left, or 8xy. 8yx is the same as 8xy. What about the other one? Plus 3xy is the next one now. To differentiate 3xy with respect to x, that means I'm going to treat my y as a constant. Like saying I have 3, 6x. If I differentiated this, what would I have? 3, 6. So that means my derivative will be 3y. Then plus 4y squared. Differentiate 4y squared with respect to x. It's going to be 0. Because I'm going to treat my y as a constant. Because I'm going to treat my y as a constant. Kingsmate, is it showing up? Kingsmate, is it showing up?
They can see it. You have to manage it. There's not enough light.
Sorry about that. So the f the x is now simply 6x plus 8yx plus 3y. Now the f the y is going to be treating x as a constant, right? So I'm having 2 times 3. That's going to be, sorry, I'm treating x as a constant. So this is totally going to be 0 plus 4x squared y. So I'm treating x as a constant. Do not forget that. So I'm not bothered about the value of the power of x. I have 4x squared y. But if x is a constant, I'm differentiating with respect to y. What I have here is simply 4x squared plus 3xy. If I differentiated this, I'll be having 3x as the derivative. Finish. And 4y squared, differentiate with respect to y. That's going to be 8y. So this is the derivative with respect to y. This is a partial derivative of f with respect to x, and this is the partial derivative of f with respect to y. That is what I call partial derivative. So that is what is called partial derivative, partial differentiation. And the d, anywhere you encounter it, your d is different from normal do. It is not df dx, and it is not delta f delta x. They are two different things. Three different things. This is an infinitesimal change in f with respect to x. This is the normal total derivative of x, f with respect to x. While this is a partial derivative of f with respect to x. This one can be used in implicit differentiation, while this one is used in partial differentiation. So let us talk about higher derivative, higher differentiation. Higher differentiation is mostly used or is very used in all these iterative methods. Let's say I'm using the trapezium rule. Let's say I'm using the Maclaurin's rule now. I need higher derivative because it depends on the number of series, of terms in a series. So let's say I have f of x now equals to, I'm not going to partial derivative right now. F of x equals to 3x cubed plus 7x squared plus 2x. Now, find f prime of x, find f prime of x, find f triple prime of x, and let's stop here. I'm not stopping there. Find f odd prime of x. What is f prime of x? That is the same as the derivative of f with respect to x, like the y dx. But this is not y. So I'm going to say, okay, I can write y is equal to f of x. So I can write the y dx. If you do not get it, please let me know. My f of x is equal to the y dx. F prime of x, rather, is equal to the y dx. And that is equal to, differentiate this, 3 times 3x raised to power 3 minus 1. That is 27x raised to power 2 plus 2 times 7x raised to power 2 minus 1. That's 14x plus 2. This is the first derivative. This is the first derivative. We've just differentiated first. What's going to be the next one? That is the second derivative. That is f double prime of x.
3. Is it 3 raised to power 3 or 3 times 3?
It is 3 raised to power 3 or 3x raised to power 3. Okay, 3 times 3 is 9. Oh, no verse, Jared. I'm always making this mistake, almost every time. I remember I just put it in and reminded me. The last video I made. That was it. 3 times 3 is 9 verse. 27, right? So f prime of x is equal to the squared y, the x squared, or the square y, the x2. That is what? The second derivative of y with respect to x. I will not write it as the y dx. I'll write it as the squared y, the x squared. These are Leibniz notations. So now write this as, differentiate this one now. This is 18x plus 14, right? So go to the third derivative, f third prime is going to be the cubed y, the x squared. So this is going to be 18 plus 0, right? So the fourth derivative of x is going to be the fourth y, the x to the fourth power is equal to, the derivative of 18 is what? 0. I'm sure almost everyone has gotten what we mean by higher derivatives now. Higher derivatives simply means differentiating the terms consecutively. Or let's say, differentiating a preceding term to know the value of the next derivative, differential coefficient. So let me do another thing. Don't forget that this one is not even partial differentiation. There is still higher derivative in partial differentiation. So let me say I have f of x is equal to y is equal to 4x squared plus sine theta. So find the first derivative, that is dy dx. Find the second derivative, that is squared y dx squared. And find the third derivative, cube y dx cubed. What is that going to be? My dy dx is going to be 4x squared will become 8x plus sine theta becomes cosine theta. I differentiated the both of them using the sum rule. Differentiate this, add the derivative of this with derivative of 4x squared is 8x, and derivative of sine x, sine theta, let me use x, sorry. Sine x is cos x. Now, the squared y x squared means the second derivative. So differentiate 8x, that is 8, plus differentiate cosine x, that is minus sine x. So what do I have there? 8 minus sine x. Then the third derivative is going to be 3d cubed y dx, which is equal to differentiate 8, that is 0, plus differentiate minus, or like this, 0, this is what I'm differentiating, minus, this minus. Now differentiate sine x, that is what? Sine x. That means if the cubed y dx cubed is equal to minus cosine x. What have we done? We've done higher differentiation. You might be given this kind of code to know. So this is dy dx. It's the same as f prime of x. This is the squared y dx squared. It is the same as f double prime of x. And this is the cubed y dx cubed. The same as f triple prime of x. Please, are you guys getting it? Let me know. If there is a question, just let me know. Or if you're confused somewhere. That means nobody is left behind now. I'll take it that way. I'll assume nobody is left behind. All right. So let us now look at partial derivative when I'm having more than one issue. So this is f of x comma y. That means f is a function of two variables, x and y, is equal to 3x squared plus 4xy plus 4x squared. Now the thing to find now is the partial derivative of f with respect to x. That is the first problem. The second problem is the partial derivative of f with respect to y. The third problem is the partial, the squared f, the x squared. That means the partial derivative, the second derivative of the partial derivative, the second partial derivative of f with respect to x. And the squared f dy squared. These are the things we are looking for. No confusion. Let's look for the first one. The f dx means what? This is 3x squared. I'm differentiating with respect to x. This becomes 6x. Plus, I'm differentiating with respect to x. This becomes 4y. I will treat y as a constant. I will always remind you that I'm treating y as a constant. So I'll be having the derivative to be 4y. Plus, differentiate. I wrote 4x squared. 4y squared with respect to x is 0. So this is the f dx. I now, the f dy. That's going to be what? 3x squared will be 0 plus 4xy differentiated with respect to y will be 4. What did I write? Okay, will be 4x, right? Because I'm treating x as a constant. Plus differentiate 4y squared with respect to y. That is 8y. So now let's go to the e squared f bx squared. That is simply d dx times df dx. Abi, that is it. This is equal to, that means the derivative of this thing. What is this thing? 6x plus 4y, right? The f dx is 6x plus 4y. So the derivative of 6x plus 4y is what? With respect to x, do not forget that. With respect to x, that's going to be 6. Finish. Now the derivative of the squared f dy squared means the derivative of d dy, so of the f dy is going to be 4x plus 8y. The derivative of 4x plus 8y with respect to y is going to be 4x will become 0, right? Because it's a constant now. And 8y will become 8. That is the case. Let me rub this place off. Give a more interesting.
Hello.
Hmm?
Please, can you make the camera stable? I want to screenshot the left-hand side. Okay, I'm done. Thank you.
Okay, so take this as another case. F of x, let me go to 3. Now, f of x comma 1 is equal to 8x cubed plus 4xy minus 3x squared y squared. The first problem now is to find the f, the x. Second problem is to find the squared f, the x squared. The third problem now is to find the x of the f, the y. Sorry, find the other one. Find the f, y. And the fourth one should be the x of the f, the y. The fifth one is d dy of the f, the x. The sixth one should then be d squared f y squared. Have this here now. So let's go ahead and 6 factorial 1 to 6 over 1, 2, 6 factorial is 120 and 720. 720 we take. So solution. This is what we have as our f of x comma 1. And the first problem will be tackled this way. The f, the x, is going to be the derivative of this thing with respect to x. That is treating y as a constant. So I'm going to add one other thing to it, plus 8y squared. So 8x cubed with respect to x is 8 times 3. For those of you that don't want to give anyone, that's 24x the second form plus 4xy now with respect to x with yours or y. Just treat your y as a constant. As you're writing 4, you're writing 1 minus 3x squared y squared. 3x squared y squared with respect to x. Treat y squared as a constant. X squared times 3, 6. It becomes x, right? So 6x y squared plus 8y squared. Everything is a constant. When x is 0. So that's 0. We've gotten the first answer. This might be a question. It might be in this form, or it might be in this. So,
Excuse me. Please, what is the derivative of any constant?
0 everywhere.
Okay.
Whenever, whenever you treat something as a constant, means you are taking it as a number, something that's not changing. It's not a variable like this x and y. You see, 8 is a constant. Derivative of 8, because 8 is always 8, it's a constant, it's not changing. It's uniform. Derivative of 8 will always be 0. Now we treated our y as a constant. So the derivative of y will become 0 at least. So the
Okay.
derivative of any constant is equal to 0. So dx of any constant is equal to 0. Take this somewhere. We treat our c as a constant.
Okay.
So the squared f dx squared means, look at what I'm going to do here. The squared f dx squared means dx, that means the derivative of, if I wrote the dx of 3x squared, you don't have to stress yourself. Know that they're asking you to derive this and to differentiate it. That is the meaning. So the derivative of what? Look at what it says. I have d squared f x squared. That's going to be d times df over the x times x. So I'm going to differentiate what I have. That's d dx of, what is the f dx? The f dx is given as 4x squared plus 4y minus 6y squared. Now differentiate that one too with respect to x. Do not forget partial differentiation. Yeah, 24x squared. That is 28x plus 4y. 4y will reduce to 0. It's a constant. And minus 6y squared. 6xy squared will become minus 6y squared. That's treating y as a constant. Oh, I differentiated this straight. Sorry about that. Instead of differentiating straight, what I have here is dx of both of these things. So this is dx of all of that thing is what? 24x squared plus 4y minus 6x y squared. So this is equal to, now dx of this thing means differentiate it with respect to x now. That's going to give me 48x plus 0, right? So minus, treat your y squared as a constant, treat your 6 as a constant. That is 6y squared when I differentiate it with respect. The third one is d f y. This is your f. Always remember. The f dy means differentiating f with respect to y. That means 8x cubed becomes 0. 4xy, treat your x as a constant. It becomes 4x minus 3x squared y squared. Treat your x as a constant. So I have squared here 2 times 3, 6, and your x squared is a constant. I'll be left with a y, right? So, so I continue. Plus 8y squared, differentiate that, that is 16y. I've just differentiated the function f of x comma with respect to y. That is a partial derivative. So the fourth question is e dx of f y. Now, you have to be very, very attentive. E dx of f dy means differentiate with respect to x, the derivative of f with respect to y. What is the derivative of f with respect to y? 4x minus 6x squared y plus 16y. I want to differentiate this thing with respect to x. You know, this was gotten by differentiation with respect to y. Now, what I have here is to differentiate it with respect to x. Now, let's do that. 4x will give me 4 minus 6x squared y will give me 12xy. I'll treat my y as a constant. I'm going to end the class in jiffy, just a few minutes more. And 16y will become 0. Is it still showing like this? The solar went down. It's already extremely low.
Continue.
You can
Maybe you
just
can print out.
Finish that solving.
You can write it. Just one.
Yeah. So This is number 4 like that. So the fifth one now is to differentiate, differentiate with respect to y, the derivative of f with respect to x. That is d dy, open bracket. The f dx is what? The f dx is 24 x squared plus 4y minus 6xy squared. I'm differentiating this now with respect to y. That means the whole of 24x squared gives me 0. And plus 4y becomes ordinary 4 minus 6xy squared. That means 2 times 6, 12. I'll treat x as a constant, x, and y will be raised to a power of 4. The last in the d squared dy squared. That is d dy times df dy. So the derivative of the f dy with respect to y. We should do that yourself. So if I have any question, let's check it. So that is differentiate the f dy another time. That's it. So 4x, that means differentiate f dy with respect to y, right? So 4x becomes 0 minus 6x squared y. Treat x as a constant, right? Becomes minus 6 x divided by 12. And plus 16y becomes plus 16. This can be rewritten as 16 minus 6x squared as the derivative, the second derivative of the partial derivative of f with respect to y with respect to y. I wish everyone the best. I wish everyone the best. We're gonna have another class tomorrow by God's grace.
Let me copy this last one, please.
Eh?
Let me copy the sixth solution. That last solution.
Is there no? I can't hear you.
I said, please let me copy the last solution.
Okay.
I can see it from here.
Look at this chest value just
Please, is that minus 6x squared
yes, minus 6x.
plus 16?
I wish
Let me
everyone
get the minus.
take your time. If you believe you understand that, take your time to watch the videos that have been done. Oh, I'm very sure you have sufficient sense to answer the questions. I wish everyone the best. Let's have some stuff tomorrow. So let's have a nice time, guys.
Thank you.